We're on FRQ 266. This is interesting. It's got a function, f of x, with a k in it, where k is just a positive constant. And the first thing it wants is the first and second derivative. So we're just going to make sure we can do that. So for a, I'm going to use white. F prime of x would be equal to, okay, the derivative of k times x to the 1/2, right, would be 1/2 k x to the negative 1/2, or, and then minus ln of x would be 1 over x. So let's rewrite that a little bit better. That's, let's see, k over 2 square root of x minus 1 over x. Is that right? K over 2 square root of x minus 1 over x. So there's the f prime of x. F prime of x would be the derivative of this. I'm going to look back at that, really. So that would be a negative 1/2 times a 1/2, which is negative 1/4 k x to the negative 3/2. And then the derivative of 1 over x, that's x to the negative 1, would be negative 1x to the negative 2. So that would be plus 1 over x squared. So let's rewrite that to be negative k over 4x to the 3/2, just leave it like that, plus 1 over x squared. So we have the first derivative and the second derivative. All right, let's go on to part B. All right, B says, for what value of the constant k does f have a critical point at x equals 1? For this value of k, determine whether it's a minimum, maximum, or neither at x equals 1. Okay, so basically you're going to set the derivative, right, equal to 0. And, and then put x, yes, and then put x as 1 and see what k comes out to be. So do you understand that? So let's write it down. We have what value, what's a critical point? So we know, if I go back and look at my derivative, I'll rewrite it. So f prime of x is equal to, and you guys don't need to rewrite it, but k over 2 square root of x minus 1 over x. So this is, since it uses a, you guys better make sure your b is right, your a is right before you do your b. So we're going to set that equal to 0, but we're going to say that at this time, when does it have a critical point where it equals 1? So we're going to say x has to be 1, right, at this point. So we are going to say that k over 2 times the square root of 1 plus, or minus, substituting in 1, minus 1 over 1 is equal to 0. So k over 2 minus 1 equals 0. So k over 2 equals 1, or k is equal to 2. So that's the first part. It said, for what value of k does f have a critical point? So when k is 2, it has a critical point at x equals 1. For this value of k, determine whether it's a relative minimum, relative maximum. Well, they already told us that the critical point was 1. So let's rewrite the derivative with this 2 in it, and then do, we're going to have to do a sign chart because this can't use end behavior. So 2 over 2 square root of x minus 1 over x. Okay, that would be our derivative. So let's try, and this is for greater than 0. So we're going to have to use, let's use a fourth because we know the square root of a fourth. So this is, cross that out. That would be 1 over the square root of 1/4 minus 1 over 1/4. So the square root of 1/4 is 1/2. So this would be 1 over 1/2, or 2, minus 1 over 1/4, which is 4. So you get a negative. And then let's just use like the square root of 25. So that would be 1 over 5 minus 1 over 25. And, okay, hang on. 1/5 minus 1/25 is definitely positive. So I froze. Come on, pen. Oh no. So I had to charge up my pen. So we got positive here. So at x equals 1, f has a critical, no, not a critical point. It has a minimum, right? Because f prime of x changes from negative to positive at this point. All right, so that was B, and let's do C. So C says, for a certain value k, the graph of f has a point of inflection on the x-axis. Find the value of k. Okay, so value of k has a point of inflection on the x-axis. Okay, so that means that if it has a point of inflection on the x-axis, that means that f of x has to be 0. Because on the x-axis would be making f of x equal 0. So we have to go all the way back up to the very first thing and set that equal to 0. So 0 equals k times the square root of x minus ln of x. By the way, most of the thinking is in that. The point of inflection on the x-axis, okay? And you know what a point of inflection is. It means what's happening on the graph, and it's on the x-axis. So remember that we have k of x minus ln of x. So k square root of x equals ln of x, and k is equal to ln x over the square root of x. So we just have k. Remember, we don't know what k, it's any time, so we can't use the 2. And then we have also, it also means that the second derivative, right, it has to equal 0. That's where the point of inflection is. So 1 over x squared minus k over 4x to the 3/2 has to be equal to 0. So let's just solve for k again. So we get 1 over x squared equals k over 4x to the 3/2. So k, cross multiply, k squared equals 4x to the 3/2. So k is 4x to the 3/2 over x squared. So subtract your k is equal to, this is k, 4x to the 3/2 minus 4/2. That's subtracting 2. So k is 4x to the negative 1/2. All right, so I have these two k's. If I set these two things equal to each other, I'll solve for x and then go back and find k. So ln of x over the square root of x is equal to 4 over the square root of x. So you have ln x is equal to 4. So e to the 4th equals x. So now go back up here to find k. So if I have k is ln of x, which is e to the 4th, over the square root of e to the 4th, then I get k is equal to 4 over e squared. And that's the right answer. K equals 4 over e squared. So that was part C. That was a little weird, but nothing you couldn't do if you thought about it. All right, let's do points. So part A, all right, is worth a total of 2 points. you get 1 point for f prime of x and 1 point for f prime prime of x. All right, part B is worth 4 points. All right, so you get part 1 for setting f prime of x equal to 0. So that's 1 point. And you get 1 point for solving for k. And you get 1 point for your answer, that it's a minimum. And 1 point for the reason. So that was worth 4 points for B. Point C is worth 3 points. So that would give you a total of 9. Okay, for C, you get 1 point for setting f of x equal to 0. Or if you set this equal to 0. So now you don't get both those points. So this is an or. So if you did nothing else, if you set one of those two things equal to 0, you get a point. So if you get the equation in one variable where you solve for x, so you would get, when you get this, plus 1, you get, if you got that far, you get 1 more point. And if you got 4 over e squared, you get the third point. All right, so that's FRQ 266.